So this weekend I worked on a lab in my emulated environment in EVNG. It's basically just a overview of a provider network, like a service provider that's providing internet across the country. We do have like a secondary ISP in here. Really, all of these, like each state that has the two routers next to each other, those are all going to be iBGP, so internal BGP peers. Anything that's going to be different, so from here to here, between Montana, Washington, or North Dakota, Montana to Colorado, Colorado to Missouri, all those are going to be external BGP peers. So that's it on the provider network. I'll get into kind of why I'm using what, but I just want to do a quick overview of what the network is. Up in Washington, we have a managed service provider or an MSSP for managed services networks. Over in North Carolina, we have like our corporate headquarters for a customer that we're managing. And then they also have a satellite office that's in Chicago. So this is just a logical map that's easy to view everything. I did notice that I forgot to put in the connections between Nashville and St. Louis. So what we're going to do is we're just going to close out of this, and we're just going to look at this from just, the EVNG ugly topology that I haven't really cleaned up. So up in the top left, we have our MSP business or whatever. They have a Juniper SRX series firewall, and this is just a virtual firewall. All these are virtual right now, but with EVNG Pro, which I have, you can start linking in physical hardware with this topology. And I noticed that I've been fighting a lot of things that are on the EVNG side or vSphere side with VMware, which is what I'm actually hosting this VM on. And then everything's kind of like double virtualized, so like EVNG is virtualized and then on VMware, and then all of these devices inside are all virtual machines inside of EVNG, inside of VMware. So I've noticed I've been fighting a lot of the EVNG setup parts and not necessarily the network component. So like I said, we have our MSP business up here. They are going to create, so they have, this is the main reason of like why BGP has been implemented, because you could set all this up on OSPF, although it wouldn't really kind of be right. You kind of want to set up like OSPF between like all the St. Louis stuff, and then maybe they go down to another area and have like a stub area or whatever, but then you'd still have BGP between the different service providers themselves, similar to how like St. Louis and Nashville are different AS numbers, whereas both of St. Louis is the same. But the big thing is they have a public subnet, and they actually have a /24 in this model. It's like 172.19.0.0. They use this to monitor via tunnels on their customer equipment, or for like the FortiGates, if they had like FortiManager, they would all host back. So if the FortiManager's hosted, and I'm just going to use the loopback address on this SRX, so to explain this. So if we take a look at the loopback address that we have, the loopback is going to be 19.0.254. So let's say we were natting 254 to something, or we had that internal. Basically what we're doing is we're advertising our whole subnet of 172.19.0.0/24 to both internet providers, both Washington and Montana. So that way they have one IP address that their tunnel's coming back to, or that if the FortiGate was, I don't have licensing for it, but if FortiGate was through FortiManager, they would come back through that as well. So this is going to lead us into the reasons why BGP is big and used and what it is. So the first one, we're going to get into filtering, right, with route filtering. So for instance, you want to filter both sides. So as a customer, you wouldn't want to just, no matter what, hand out all your routes, unless of course you needed to, but it's going to be on a use case. Same thing with like an ISP provider, multiple reasons for that. You wouldn't want to just advertise all your routes out. One, this SRX would not be able to handle all the routes from an actual ISP router or their equipment. Two, privacy reasons. Same thing as for the customer side, same thing on their side. They're not going to want to route these other things out. Now they are going to have the routes inside theirs, so once the traffic gets from the customer's device to the provider device, the provider device is going to be able to route it. And if it doesn't know where to go, it's going to end up having a default route, and it'll all get routed out unless the route just doesn't exist. So we're going to go between this Montana device, and we're going to go with this SRX device. And what we're going to do is we're going to show the filtering both on the Juniper SRX side and on a Cisco router. So on the Cisco router, first thing we're going to do is we're going to do a show run, and we're going to just do it for the section of BGP. This is just show us the route map and how it's associated per neighbor in or out. And then the same thing over on the SRX, we're going to do a show config for, I think it's like policy options. Yeah. So, and then I would have to look at, I think it's under the BGP settings next. So show config protocols BGP. So what we have here is we have a group of peers, and then this is how we're actually like making our neighbor statements here. So then the type are going to be external. This is just the name, external peers, just how I called it. And then our export is going to be the policy statement. Like, what policy statement do we match to export routes? And then the neighbors that we want to route to. Now the nice thing with that is, let's say you have a bunch of IBGP or a bunch of the same peers, right? We're using the same AS number multiple times. You can actually just set what the AS number is, and by default, if you don't include neighbor IP and then the peer AS number, it's just going to use whatever the AS number you set was. Can be nice, but if you don't know about it, you can also break quite a bit or wonder why you're not getting neighbors being formed. So we have both of these are different, so they're both set as different ones. They're both using the same policy, and that policy is to filter an exact route prefix of 172.19.00.24. If it matches that, then we're going to accept it and we're going to send it, or we're going to export it in this case. You can do, I think you can do import as well, but in this case, I'm doing it on this side. So if we look at the Cisco side of things, when we're under our BGP autonomous system. So for our neighbor of 0.5, which is going to be the SRX in this case, we're going to use a route map called BGP outbound filter, and we're going to filter out. Same thing how this you can do export or import, you're doing in or out. So then if we do a show route map, we can actually see that route map. So what it is it is a deny. So it's going to match based on this BGP access list, and then it's going to deny it. So if we show IP access list, we'll see this BGP filter out access list, and we can see it's actually matching 8. So what it's doing is it's saying match on, and then 172.18, and then it doesn't care about the rest. And if it matches, then it's going to come up to this, since it's in this route map, and then the route map's going to eventually deny it. So if we do a show IP route 172.18.0.0/16, we can actually see the 8 routes that it's going to match on. Yeah. And so it's not going to advertise any of these routes out. Now a way that we can confirm that is we can do a show IP BGP neighbor, and then we're going to do 172.19.0.5, and then we're going to do advertise routes. This to show us, hey, we're not sending any. Same thing, we can actually see like, hey, what kind of routes are we getting from this guy? So you can do a question mark here, you can do received, or you can do routes. So we see, hey, we're learning that /24 that we talked about. That's being filtered up here. Same thing, so if we did a show route on this side, we can actually see that we don't have any 172.18 routes. They've been successfully filtered out. So that's route filtering on a SRX and on a Cisco device. Juniper router is going to be the same. They're going to use those policies that we set and just looked over. And then, of course, the route prevention, like the route loop prevention. Basically, anytime a route goes somewhere, it's going to be stamped with an AS number. And if that router sees that AS number twice, if it's not configured specifically, it's going to drop that packet. So that's pretty much it for this provider, for the provider network, just on a BGP level. I do want to kind of expand this at some point. break down into more regions, and then have included like more IBGP or almost like data centers or something, where I'm going to have a bunch of subnets just to allocate out, instead of just like, oh, Illinois, you have a 1 slant 24. Oh, Montana, you have a 1 slant 24. So I'd like to break that down more. But I do need to figure out with my resources how I'm going to do that, because I'm pretty much maxing out this machine as it is, and especially when you start or stop things, they take forever now. And then making it just more robust, make it quicker. So what we'll do is we'll eventually test the failover on this. So if let's say this MSP business, in order to get down to North Carolina, the way that they were being routed was across the top of the country through these 4 routers and then down to Charlotte. Let's say Illinois had failed. So at this point, the only way to go would be to come down through Colorado. Now you could come all the way down, but I have these routers turned off right now. I turned some of these off to try and save some of the resources. But you'll see how it could be tuned by editing those timers. So you can edit like the BGP timers, similar to how you can edit like first hop redundancy or even OSPF timers. So it could converge quicker. But one thing you could do too is use like IP SLA on top of OSPF, kind of regionally, in order to know when devices are up and down quicker and not have to wait on that extended timer from BGP, because the OSPF, you're going to be looking at like your metrics depending on if it's internal BGP or external BGP or OSPF to add that route into the routing table. So there's more I can do with it, but I'm pretty happy with how far it's come so far.